Okay, if I have eight bits, which is either a 0 or 1 for each one of these, I can represent and store quite large numbers with just 8 zeros and ones. So at the moment, if all these bits are actually all 0, I will have the number 0. If I change one of them, like this one, to a 1 instead of a 0, I now have the number 1. If I add another 1 there, I now have a 1 plus a 2, which means I have the number equivalent of the number 3 stored. If I add another 1, so 0, 0, 0, 0, 0, 1, 1, 1, I now have a 4, a 2, and a 1. 6, 7. So I have the number, the same as a decimal number, 7 stored. If I add another 1, I have the 7 plus 8. So I have equivalent of number 15 stored. Now you might notice a pattern here. Interesting enough, if all these are 1, the very next number here, 2 to the power of 4, or this one here, is equivalent to 2 to the power of 4 or the number 16. If this is a 1, this at the moment 1, 1, 1, 1, 1, it's 15. But if this one's a 1, look what happens to get the number 16. All the 1s switch to 0, and then the next one over changes to 1. So if I shift this 1 across one column, what's happened to the number? It's doubling because it's going up by the power of 2. So this number here, for instance, this number here is 128. To get 129, I add a 1. If all these are zeros, if all these here are 1s and this is a 0, that number would be 127. When they all switch to 0 and then just 1, it goes to 128. So using zeros and ones, you can store any number. And this is with 8 bits. So try and think about what would happen if I added another bit. What would the number this number be? And what's the largest number I could store?